Today we're going to talk about Chapter 12. We'll talk about your research proposals a little bit. I'm using examples that are from your studies or your proposals. And so hopefully that will help you get a better sense of how all of this works. So Chapter 12, a little bit more about experiments. So we talked about surveys. So Chapter 4 basically introduced these concepts. We talked about surveys a little more. Chapter 10, we talked about correlation studies a little more. Chapter 11. Chapter 13 actually goes a little farther into depth into experiments, but we're not going to include that chapter in this class. Of course, if you want to go read it on your own, I'm not going to stop you. So today we're going to talk about experiments, one factor, simple experiments. That's Chapter 12. So if you are doing an experiment for your research proposal, and based on your responses to Lab 47, I believe, so there's 11 of you in the class, and I think 7 of you are doing experiments, and so pay special attention to this. So just some review: an experiment versus an observation. When you want to know how much something exists in a population, that's a study of frequency. There is no independent variable. There's no dependent variable. You're just doing a survey study, a frequency study. So for example, if you want to say what kinds of narcissism exist in this particular population, then you're looking only at frequency. Let's pretend you're saying, what kinds of narcissism exist in a population of college professors? Well, that sounds like a pretty hilarious, fun study, in my opinion. So yeah, go do that one. That'll be fun. Or what kinds of narcissism exist in people in leadership positions? Also super interesting. So that would be a frequency study. There is no independent variable. There's no dependent variable because you are not manipulating anything. All you're doing is looking. Make sense? Hope that clears it up a little in case you still had some concern. Does one variable go with another variable? And so if you're looking to see if one thing goes with another thing, or if one thing can predict another thing, then you're looking at an association study. And again, you're not changing anything about the study. You're just collecting information and then correlating it, relating it to each other. And so since you're not changing anything, you're just looking again. The only difference here is you're looking at more than one thing instead of just one thing. So in our study of narcissism, we're just looking at one thing, narcissism. In our study of association, we're looking at 2 things. The example here is extroversion in people and extroversion in pets. Do extroverted dog owners tend to have pets that are more extroverted? So you're looking at a correlation between the kind of pet they have and their level of extroversion. So a survey and an observation or a association study, neither of those can determine cause. You remember, correlation is not causation. And so when you do those kinds of studies, all you can say is, this is what we found, this is what we observed. You can't say people who are extroverted are caused by extroverted pets. No, you just say there's an association. They tend to do that, or we can predict their behavior. We can predict, if there's a high correlation, then you can in the future predict that an extroverted dog owner will probably have an extroverted type of breed of dog. All right. An experiment, however, can or might determine cause. There's still rules. It's still hard to do. But with an experiment, it is possible. And so the scientific method will help us figure out how to run an experiment in order to be most likely to attribute cause correctly. The thing you don't want to do is attribute cause to something when it was really something else that caused it. And that's why we have to be very careful about the design of the experiment so that it has internal validity. In other words, we're just going to keep pounding this concept over and over. Internal validity meaning that the results you got were due to what you changed about the independent variable, not because of some other outside variable. And so an experiment can determine cause if and only if all the other variables are accounted for and controlled. And that's where the challenge is, because you may not know all of the things. So if you know all of the things, that's unlikely, but if you do, and you can control all of the things, then you can be pretty confident in saying, well, this is the cause. You can do that much more easily in a lab setting. The problem then is maybe the lab setting isn't the same thing as real life. And there are variables that happen in real life that weren't in the lab that may change the relationship between your variables. And so we remain cautious. We're always cautious. We usually don't say that we've identified a causal relationship. There has to be so much data. You have to have like the weight of the data, the bulk of the evidence, et cetera, has to be so overwhelming for us to be able to use that C word of cause. For example, I read some years ago now, I read an article that talked about how poor sleep is found to be causal in depression. And I was like, whoa, that is a big deal to use that word to say it is causal. Certainly, lots and lots of studies have found that poor sleep is associated with depression. And then you have the question of which direction is the association. Does poor sleep make you depressed, or does depression make you sleep poorly? And so here, enough evidence had been gathered over time with lots and lots of different studies that people could be pretty comfortable in saying poor sleep can cause depression. And so we've identified causality and the direction of that relationship. Certainly, depression can result also in poor sleep and sleep difficulties, particularly waking up early. And that is a little different idea than what we're talking about with poor sleep, not necessarily waking up early and having that particular kind of poor sleep, but just really poor sleep schedules, poor sleep hygiene, very little sleep, going to bed way too late, etc. Those kinds of things can be causal. They can be. We don't necessarily say we are, because as scientists, we are super cautious. That's the other C word, very cautious about causality. So what makes an experiment different than from an observational study where you're just looking, or an association study where you're looking at least two things? With an experiment, the thing that's different is that you are manipulating a variable. So if I'm observing narcissism in a group of people, I'm not manipulating anything. I'm not changing anything. There is no independent variable. I'm just looking to see what the frequency is. Or if I am looking at the relationship between extroverted dogs and extroverted people, I'm not making any changes. I'm not changing a variable. I'm not manipulating a variable. I'm just looking. I'm looking, and then I'm correlating two things, correlating extroversion in people and extroversion in dogs. And so I'm looking at that association. No variables have been manipulated. With an experiment, you can keep all the variables the same except for the one that you change. And so with the experiment, you identify the one variable that you do want to manipulate, and then your goal is to identify all kinds of other variables that you can hold the same. So those are what we call controlled variables. And you generally try to control for the variables in particular that you think might also have an effect on that outcome that you're looking at, on the dependent variable. And so in terms of an independent variable, there are a few ways to do it. You can have different levels of the independent variable. You could have it exists or it doesn't exist. You could have, here's some of this, here's more of it, here's a lot of it. That's maybe 3 or more levels. You can have, here's a little bit of this, here's a lot of this, that's 2 levels. There are various levels of an independent variable that you can have. Again, your goal is to be confident that the results you got, the impact of your independent variable on your dependent variable, on your outcome. Those results are the result of your manipulation, not the result of some other variable. So any other variable that might also be responsible for changes in your dependent variable, that is called a confound. It is a threat to internal validity. And so in your proposal, when you write up the discussion section, you're going to discuss potential threats to internal validity and potential threats or your thoughts about external validity. And so be sure you do a lot of thinking about this. Talk about it with your friends, your mom, somebody, just to try and explain it. Maybe that will help you as you think about it. So here are some examples, and these examples are from you and your study thoughts. And so if we're looking at the effect of milk chocolate on sleep quality, what are some of the confounds? So first of all, let's look at this as an experiment. The independent variable is whether or not you have milk chocolate. The dependent variable is how's your sleep. That's the outcome. That's what we're looking for the effect on. We want to know what's the effect of whether or not you have milk chocolate on how you sleep. And so that's the dependent variable. And so you could have levels of the independent variable. You might have 0 chocolate and some chocolate, or you might have more than one level. You might have no chocolate, some chocolate, more chocolate. You know, you can determine how you want to look at it. Maybe your preliminary research has showed that a small amount of milk chocolate doesn't really make a difference, and you just want to confirm that. Maybe you want to say, could you eat like 1 square of a Hershey's, or could you eat the whole bar? And that's what you want to figure out. So then you create those levels of your independent variable. The key is you can manipulate how much of the independent variable the people in your experiment get. How much milk chocolate they get, you're manipulating that. That's the independent variable. And so this is an experiment. The confounds, well, you know, it could be that some people sleep poorly no matter what. It could be that some people are so exhausted that they actually need a little bit of stimulation to sleep better. And so a little milk chocolate might help them. It could be that the people who are sleeping well have better sleep hygiene. Or it could be that the temperature in their room is better. Or it could be that they're less worried about things. And so there are lots of other reasons or other ways to affect sleep other than just milk chocolate. So some of these are confounds. Anything other than milk chocolate that does affect sleep is a potential confound, and you want to control for that. One way, and this is important to recognize, one way to control for all those many other variables that might affect sleep, one way to control for that is through random assignment and having enough people in your study. And so if you pick 4 people in 2 groups, one group doesn't get milk chocolate and the other group does, and you only have 4 people, if one of those people always has really great sleep no matter what, they're going to skew your results. So your results are not going to look like they normally should look because you only have 4 people and one of those people has really great sleep no matter what. So you're not getting a true idea of the impact of your independent variable on the dependent variable because that is a confound. One of the people always sleeps well. So you need more than 4 people, right? The bare minimum for most experiments, depending on your variables, the bare minimum for group membership is thought to be about 15 people per group. I prefer to have it higher because I think the more people you have, the less likely it is that any one of these variables from one person will affect the whole. So, you know, maybe 30 people per group might be a good plan. So that's one example. Next example, you're looking at the effect of temperature on how well you study. And so the temperature might be, let's say you study best in a temperature that is about 72 degrees. And that's where I like it. I like it when it's about 72. And that's where I think I'm more effective. My body starts to notice when it's 74. And I find that if I'm in front of the thermostat and wanting to turn it on, it's almost always because it's 74 or higher. And I'm having trouble focusing. And so there's an effect of temperature for me on the quality of the work that I can do, on my ability to concentrate. And so you can manipulate or change the temperature. And so let's say the study is looking at a temperature of 72 versus a temperature of 65 versus a temperature of 80. There you have 3 levels. Okay, so just looking at, I'm not saying you have to have 3 levels. I'm just saying that this is an example of where you might have 3 different levels of an independent variable. 65, 72, and 80. Those are 3 levels of temperature. So your independent variable has 3 different levels, and the dependent variable, or the outcome, is the quality of your study. So you have to figure out, how am I going to measure the quality of my study? That's what we call operationalizing the variable. You're operationalizing it by figuring out how you're going to measure it. And so the confounds might be that maybe I'm a person that a temperature just doesn't affect me. Maybe I have a thyroid disorder, and because of my thyroid disorder, I really have trouble regulating my body temperature. So this is what happens with people who have thyroid problems. They have a real hard time regulating their body temperature. That is going to be a confound. And so what you probably would want to do if you're doing this study and thinking about different confounds, it's unusual to think that you would just know that out of the blue. But you might think, all right, so I need to make sure that either people don't have an active thyroid disorder, or if they do, that they're medicated and they're fine with being able to regulate their temperature. Or maybe there's some other reason why they don't regulate their temperature very well. Or maybe they're always cold. You probably know people like that. They're always cold, or they're always hot, or whatever. And so you want to think about, how can I control for that? Am I going to include or exclude certain people? Is there exclusion criteria that I'm going to put in place so that I can do a better job of controlling? The cost of that is, the more exclusion criteria you have, then the lower your external validity is. And so if I have exclusion criteria, let's say if you have any sort of a thyroid disorder, you can't be in this study. Well, then I could say, well, my results apply to people who don't have thyroid disorders. And so I've already eliminated a chunk of the population that my results could apply to, but don't, because I excluded them from the study. So hopefully that helps elucidate or make more clear the impact of inclusion and exclusion variables. They're very useful in order to eliminate confounds. The only issue is that they may also limit your external validity. And so you can never have the perfect study that is completely internally and externally valid. There's a balance. Usually the more internally valid it is, the more difficulty you have with external validity. That's sort of just the compromises we make as scientists. Okay, next example, the amount of time on your phone and sleep quality. So let's say you're spending, 17 hours a day on your phone versus, let's say you're spending 3 hours a day on your phone. Does this affect your sleep quality? And so here again, you're looking at the level of the independent variable. You could do this as an experiment, or you could do this as an observation or association study. Either one will work. It just depends on how you want to set it up. So if you're going to do this as an observation study, then what you do is you measure the amount of time people spend on their phone, and then you measure their sleep quality, and you correlate the two. It's that simple. You just correlate how much time on your phone. That's a continuous variable. It's tracked on your phone. And then you correlate sleep quality, and you can measure sleep quality in a number of ways that will give you a continuous variable that then you can use a Pearson R correlation for. So that's one way to do it. That is an observation study. It's not an experiment. If you want to do this as an experiment, Then what you can do is assign people to have a certain amount of time that they can spend on their phone. And so if you're assigned to spend 3 hours on your phone, or and your phone automatically turns off once you've hit 3 hours, that sounds kind of miserable, doesn't it? Or you're assigned to say you have to spend 6 hours on your phone. Well, you may not love that either. So you may not get really great compliance with that, but you might get really great compliance. The other problem is that confounds happen where people might be doing other things that affect their sleep. What if there are certain people that are on their phone very little, but then they're drinking like 2 Cokes before they go to bed? So their sleep quality is going to be affected by something different than the phone. The number of Cokes they drink per day would be a confound, and you would have to control for that confound. You can just kind of think about what are the things that affect sleep that are not amount of time on a phone, and then figure out how can I control for those. So do I tell people no Coke when you're in this study? What if people are really kind of addicted? Now they've got these horrible headaches and that's interfering with their sleep. Okay, so that could be a problem. So hopefully you see the impact of a confound here. Okay, last example, what kind of exercise, cardio versus weight training, is better for lowering anxiety? And so here we're looking at type of exercise as the independent variable, and you have 2 levels. One level is cardio, one level is weight training. And the outcome, the dependent variable, the outcome is the amount of anxiety the person has. And so what are some of the confounds there? Because obviously there are more things that affect your anxiety than simply the type of exercise you do. So you want to think about some of those things and control for those. How much sugar you're eating, certainly that affects your anxiety. And so if you have somebody who is doing cardio and they're eating a lot of sugar also, and then their anxiety may be affected by the amount of sugar they're eating, and the cardio might not be powerful enough to take away that effect. And you've got another person also doing cardio who eats a ton of fruits and vegetables and who meditates and who maybe takes passion flower. And so they're not anxious. So you want to make sure that they're not taking something that will interfere with anxiety. You want to make sure that what they're eating, what they're drinking, like again, how much Coke they're drinking, that will affect your anxiety, etc. There are lots of confounds. In other words, other things that affect anxiety that you have to control for in this experiment. And so you could just make a list. What are the things that affect anxiety? You can make this list by going to the literature. So you go look it up, go to PubMed. You could even start with a Google search, what affects anxiety? And then you get a kind of a basic idea, and then you go to the literature and get scientific support. So let's pretend you Google what affects anxiety, and what Google comes up with is something like food affects anxiety, caffeine affects anxiety, and living in cities that are over 100,000 people affects anxiety. I'm just making this stuff up, though certainly caffeine does and food does. I don't know the thing about cities. It seems to me like for some people, having a ton of people living in your city might affect your anxiety. And so that gives you a starting place to look at for potential confounds. But you don't want to just believe Google. You can't like reference Google as something that's respectably scientific. And so you go look in the literature. So you go to, let's say, PubMed.gov or PubMed Central. Maybe you'll get lucky and there's some full text articles on that are available. And so you type in anxiety and caffeine, right? And so now you can have some articles that will support this, some science that will say, yes, caffeine affects anxiety. You put that in your introduction because that's an important thing to think about in your background for the study. And so the study, your background is saying, okay, anxiety might be a problem and exercise seems to help anxiety. What kind of exercise helps anxiety? Well, we're going to look, is cardio better than weight? Great. What else affects anxiety? Well, it turns out caffeine also affects anxiety. And so we're going to control for caffeine in the study. Here you're controlling for a potential confound. And so you might control for it by eliminating all the people who drink caffeine. Well, that's going to make your external validity really poor, because how many people do you know that never drink any form of caffeine? Very, very few. I mean, good luck with that, right? And so you probably want to control for it. You can use matched words. Okay. You can match your people in your groups on this variable. You can say, how many Cokes do you drink when people sign up for your study? And then everyone who drinks 2 per day gets put into 2 different groups. And so they're matched. One person in the cardio group drinks 2 Cokes a day. One person in the weight training group drinks 2 Cokes a day. One person in the cardio group drinks 3 Cokes a day. One person in the weight training group drinks 3 Cokes. 3 people in the cardio group drink half a Coke per day. 3 people in the weight training group drink half a Coke a day. And so here, Coca-Cola or caffeine is even between your groups. And that's one other way of controlling for that variable and taking care of that confound. Okay, so hopefully this discussion of all the ways to look at internal validity with your examples has been helpful. I'm going to try and keep including your examples. Okay, now we're going to talk about within subjects and between subject designs. So if you're doing an experiment, you can choose to do a within subject design to examine the effect of the independent variable, or a between subject design. And you have to figure out which one you're going to do. And you do it by figuring out which one makes the most sense for your study. It's not like there's a right answer out there, but once you look at your study, you can figure out what might be better for one versus another. And so with a within subjects, you're only looking at one group. There's not 2 groups of people, there's just one group. And that one group gets all of the levels of your independent variable. That one group gets all the levels of your independent variable. So it's kind of like you have an ABA design. You know, maybe you've kind of done this yourself. If you're like, well, I don't know if drinking Coke before bed makes a big difference. I'm going to try it tonight. And then I'm going to try not drinking Coke for 3 nights and see if that makes a difference. And then I'm going to try drinking Coke again for 3 nights and see if that makes a difference. Okay, so that's like your little ABA design. Or you might just leave off the second A and do AB, right? So within subjects, just one group of people, everyone in the group gets all of the levels of the independent variable. Usually it's like presence and absence. It's a little harder to do within subjects and have more than presence and absence, or more than 2 levels of a variable. People, you know, it's anyway, advanced, beyond the scope. All right. So you're comparing the same people at different times. You're comparing a person after level 1 of the independent variable, and then again after level 2 of the independent variable. So for example, I think I brought this up before. There's a great crossover study of probiotics. They're looking at probiotics' impact on cognitive reactivity. So cognitive reactivity basically is how much are you freaking out in your head over something? How much are your thoughts like just going nuts, and you're like pinging and coming up with all this stuff? Cognitive reactivity. And so the idea is that gut bacteria can modify that. And so if your gut bacteria is more healthy, then you will be less reactive with your cognitions. And so if somebody comes in and says, hey, your orange dress is crazy, then you don't go crazy about the orange dress. Or someone says, you know, whatever, I really hated your hot dogs, you don't go nuts in your thinking. Cognitive reactivity, probiotics. Certainly we do know that the microbiome, your gut bacteria, has a tremendous impact on your brain functioning, memory and mood, attention, focus. All of those things are connected to your gut biome. And so it's not very crazy to think that probiotics will make a difference with cognitive reactivity. And so here they have this crossover design, and they use the same people. And some of those people got the probiotic in some yogurt first, and some of those people got a placebo. They had no probiotics in the yogurt. Everybody ate the yogurt for like 6 weeks, and then they measured their cognitive reactivity. Well, it turns out that the people who ate the probiotic had less cognitive reactivity than the people who did not. And then they switched. So the people who originally had been eating the probiotic now had no probiotic in their yogurt. And the other group who had no probiotic in their yogurt now had probiotic in their yogurt. And they ate that for another 6 weeks. Now, the people couldn't tell which condition was which because your yogurt's going to taste the same. It will taste the same. And so it was a pretty good placebo unless you start noticing that you're less cognitive reactive. You're like, wow, my brain is really working better these days. I like this. And then you might suspect that you're in right now taking the probiotic, if you even knew what the study was about, right? So that's a crossover design. You had both conditions for 6 weeks, you took a test, then you had the other condition for 6 weeks, you took the test. Make sense? Hopefully. Okay. Example 2, you can do an absence of the variable and then the presence of the variable. So this is not a crossover design. It's just a design where you have not variable, yes variable. So you might have like a baseline for a month and then the treatment for a month. And what you could ideally do is assign some people to have the treatment first and then have the baseline later. Here's a big problem. What if the treatment doesn't just end and it lasts so long that the treatment effects are still happening during the baseline? So this can be a problem. So let's say that probiotics in your yogurt change your thinking for like 2 years. And so you take probiotics for 6 weeks and then you don't take them for 6 weeks, but they haven't washed out. That's sort of like the drug term. They haven't washed out of your system. They're still active. They're still making a difference. And so that would be a confound in your study, is that you didn't know enough about all the things to know that this actually doesn't wash out very quickly. And so it won't work. So apparently the people with the crossover study and the probiotics knew enough about the impact of these probiotics on the gut biome that they knew they were safe to do it and just switch over for another 6 weeks, and that there would be a good washout. So that's another example of having to do the research for your background so that you can know all the things that you need to know to design your study the most effective way that you can design it. Okay, so the example here for absence and then presence is PowerChi. That's a program, or it's a supplement package that I put together and ran as a study. Here, I didn't have anybody do the PowerChi program first and then collect the lack of PowerChi program data, because the PowerChi program is going to change you so much that I don't know when the washout possibly would be. It would probably be a year or maybe more, depending on what happened with people's data. And so I couldn't manipulate, I couldn't do what they call counterbalance those designs. And so some people get level 1 and some people get level 0 at the beginning. Counterbalancing wouldn't work because there's really no washout. And so what happened was people had their baseline information collected for, I think, 4 or 6 weeks. And then we did the PowerChi program. They took these supplements and they did some exercise for 4 or 6 weeks. And then we looked at the results. Okay, so there are some confounds with that. It might have been some other reason why they had good results. And then there are some potential advantages because they served as their own controls. It might have been a study that would be better to do between groups instead of within groups, but the constraints of what we were able to do made it so we could not do it between subjects. It had to be within subjects. This is the reality of actual clinical research, is you run into, you know, the environment that may or may not allow ideal to happen. So ideally it would have been between groups and people would have done a placebo program. It's just totally unrealistic, unable to do it. So we did the best we can, which is a within subjects design where you had absence for a while and then you had the presence of the variable, And at the end, when you looked at your dependent variable, you are attributing the changes in those dependent variables or those outcomes, you're attributing those changes to your independent variable. Okay, between subjects designs, here you're looking at 2 or more groups of people. Let's just look at 2 groups to keep it simple. One group gets no treatment. They get the placebo, no independent variable, okay? The other one gets some level of the dependent variable, or I mean the independent variable. The other group gets some level of the independent variable. And so again, let's say we're looking at probiotics. Instead of the crossover design, we're doing a between subjects design. One group gets the yogurt without the probiotics. The other group gets the yogurt with the probiotics. That's all. Nobody switches. Not everyone gets the probiotics. So depending on whatever group you end up at the beginning, that's all you get. And then we compare the groups. So instead of comparing scores at time A and scores at time B, we compare group scores to each other. The other example would, like I said, we would have one group that gets the Power T program and one group that gets a placebo program or just their normal routine. We then compare the outcomes between the groups, And so that's why we call it between subjects. We're comparing the dependent variable between the true groups. One group got the treatment, one group did not get the treatment. Many experiments you can do either way. Some of them work much better one way than another. You have to decide for yours what's going to help you the most when you're creating your internal validity. In other words, how can you control for the most variables? So there are some advantages. Obviously the advantages to one are the same as the disadvantages to the other. So we'll just look at within subjects. Advantage, you are controlling for individual variables because each person serves as their own control. So you need fewer participants. There are less like random noise in the groups because each person is doing the same thing. And so you're not going to have one person really skewing the results over in one group and no equal skewing in the other group. Hopefully that makes sense. The disadvantage is that it takes more time because you have to collect data and then do the other treatment and collect data. You can't just do it in one shot. So it takes more time. You might have difficulty with washout, like we talked about, or learning effects, which is essentially the same idea, only instead of saying the drug or the substance is in your system, it's sort of like, well, now you've learned this new skill and you can never unlearn it. And so if you learn something and you're better at it, then you have these practice effects. That's another word for it. Practice effects, learning effects, or the effect of a drug that might change things. You may never be able to have that washout. And so in that case, that's a disadvantage to the within subjects idea. And so you would want to do a between subjects study instead of within subjects if washout is not really going to happen. All right, so now that's with what within and between subjects are. If your study is a between subject study, if you decided that you want to have one group that gets placebo or no treatment and another group that gets a level or active treatment, or maybe 2 other groups that get level, different levels of the independent variable, not a 0 level, then the next thing you have to figure out is who goes in what group. How do you decide who goes in which group? So think about your research proposals here, because this is going to need to go in your participants section. So in that, you've already written sort of like a draft version of participants. And here we are adding to your draft of participants. So take note, let me say it again. In your research proposal, this section I'm going to talk about right now is something you're going to add in to the participant section to make it a little better. We started with the basics, and now we're adding a little more. First, how are you recruiting your patients? Or your participants. I know we talked a little bit about that, but really think about how you recruit. You can think about who's the population. Let's say again, it's college professors. Okay, so that's your population. Great. But how are you going to recruit them? Do they just randomly show up at your house one day? Obviously not. So you might recruit them through email. You might recruit them through advertisement in a college newspaper, etc. Figure out how you're going to recruit your participants. When you recruit, you want to make sure that you are casting a wide enough net to get a good representative sample. We're going to talk about that when we talk about Chapter 5 in sampling. But recruiting needs to be in a wide enough recruitment strategy so you're not just getting people that happen to be around Wednesday at 4 o'clock or the people that happen to read that particular newspaper. Okay, we'll talk a little bit more about that next time with Chapter 5. So how do you recruit them? How are they going to sign up? So in your participant section, you need to make sure that you state each person signed a consent form and participated voluntarily, and the IRB of whatever institution. So if for example, you're doing this study and you are at SVU, which you are, then you would say the IRB at Southern Virginia University approved this study. Even if you're doing the study, like say in Washington State or in Hawaii, it doesn't matter. The IRB at SVU is going to be the one that approves the study because you are at SVU. Then you want to say if you're going to compensate people in any way. How are you going to give them any sort of remuneration? You could just say we gave them a thank you letter. You could say we showed them a movie, like all kinds of things. Once they're in the study, once you've recruited them, then you have to assign them to a group if you're doing an experiment. If you're doing a frequency study or a correlation or association study, then you don't need to assign them to the group. And so you don't have to worry about random assignments if you're just doing association or frequency. Because here again, remember, you're just looking. You're not manipulating anything. So you're just looking. You're not making any causal inferences. So if you're just looking, nobody's in a group. They're all in one body of your participants. There's no groups. So if you're doing an experiment, however, and you're manipulating a variable, you have to assign them to a group. So if it's a within subjects experiment, they still have to be assigned to, are they in the group that gets the treatment first or not the treatment first? Which group are they in? Or if it's a within subjects like the Power Chi study, then of course they're all in the same cohort. So that's how we use the word cohort. They're in the same cohort and they'll get the same stuff at the same time. And then you have to balance that with other potential internal and external validity problems. So if you're doing a between subjects experiment, hopefully I said that clearly. You're doing a between subjects experiment. They're in the study. Now you have to assign them to a group. You should assign them randomly. If you want it to be an experiment, it has to be random assignment. If it's not random assignment, then it doesn't qualify as an experiment. Okay, say that again, because that's important. If you can't do or you don't do random assignments, then the best you can do is call it a quasi-experiment, like almost an experiment. That's the best you can do. And so between subjects, design, experiment, now it's random assignment. How do you do that? There are lots of ways. They're easy. Random number generators, have your computer do it. There's programs you just say, here are all the people, boom, make them into a random, randomly assign them to groups, 3 groups, boom. It's like so easy. You could pull names from a hat if you like to have fun that way. So that's how you choose who goes in which group. And within subjects, you randomly assign the order that each participant experiences the 2 conditions in your experiment. So for example, if you're looking at where do you study and the number of minutes you're spending studying, are you studying in the library or are you studying not in the library? So those are the 2 levels of your independent variable, library and not library. And then the outcome measure, or the dependent variable, is the number of minutes that you're spending studying. And so you're manipulating where you study and you're measuring how many minutes you spent studying. And so you could say this is a within subject study. And so you're going to divide your participants into 2 groups. One group studies in the library first and then studies in the non-library. And the other group studies in the non-library first and then studies in the library. And then you collect how many minutes they spend studying after each day or week or whatever it is. And then you can compare within the group. You can look at, did you study more minutes when you're in the library or more minutes when you're non-library? Okay, so the way you're assigning people would still be randomized depending on where you study or not. Which level of the independent variable are you getting first? So it's a within subjects design. So you're not looking at groups, you're still looking at the same people, but you're randomly assigning people to which condition they get first. Okay, which condition they get first. That random assignment will eliminate some potential systematic bias. Let me just give you a little more example on that potential bias. Let's say that you decided everyone who shows up first is going to be in the library group, and everyone who shows up in the afternoon will be in the non-library group. Well, it may be that the reason people showed up first is some reason that also affects how many minutes they study. That's a confound. And so now, instead of really measuring whether it's library or non-library, you've got a group of people who tend to do a better job or a worse job or some sort of different job of studying based on when they showed up. So that's why you want to use random assignment, so that those qualities are randomly assigned and they're balanced between the two groups in theory. Random assignment balances all of those potential other variables evenly between the groups. And that's why the more people that are on the group, the more likely it is that all those other variables balance out because of random assignment. Okay, that's an important thing to understand. All right, type of exercise and anxiety example. If you did this within subjects, you would want to counterbalance what kind of exercise you do first versus what kind you do second, if you're doing this within subjects. Again, if you're doing it between subjects, then you're randomly assigning people to the group that either does cardio or does weight loss or weight training. Here, if you're doing it within subjects, some of the subjects will do cardio and look at anxiety, and then others of the subjects will do weight training and look at anxiety. And then what you're doing is counterbalancing or deciding randomly who's going to get which kind first. Okay, people are still in the same group, they're still going to experience both, but the order that they experience the levels of the independent variable, the order they experience that in is what makes a difference. That's where you counterbalance and you randomly assign them to which condition, still in the within subjects. Okay, I'm hoping that that makes sense. We'll just do 2 more examples, or 3 more examples, it looks like, just to make sure you've got it. So within subjects, let's say you've got one group of people and you're going to do a crossover study of eating breakfast and academic performance. And so you have to figure out which people in your group are going to first eat breakfast and look at performance, and which are going to first not eat breakfast and look at academic performance. Now, here, another confound is you may have people who normally don't eat breakfast, and that's what they're used to. So that might be something you want to control for somehow. Either you eliminate those people or you have more groups. And so you might have a group of people who normally don't eat breakfast and who are assigned to not eat breakfast. A group of people who normally don't eat breakfast and who are assigned to eat breakfast. A group of people who do normally eat breakfast and who are assigned to not eat breakfast. And a group of people who do normally eat breakfast and are assigned to, yes, eat breakfast. Now you've got 4 groups. And so you experiment by changing what they're doing. They have all 4 conditions, and it would be more of a complicated study because you're going to have people doing 4 conditions. And so it will just take a lot longer to get those kinds of results. You could do it in a between subjects manner where you're just looking at 2 different groups. But you have to figure out what are your confounds and how can you best control for your confounds. And since your previous habits of eating breakfast is a pretty big confound, it might be useful to look at a within subjects method of designing that experiment. Temperature and grades, if you do that within subjects, then you can see where you would want to counterbalance the first level of the IV that people experience. So am I experiencing 80 degrees first, or 65 degrees first, or 72 degrees first? You have to randomize who gets what first. And so there's no systematic reason why a certain group is starting at 72 and maybe they have some other variable that makes them similar, like they all showed up early, for example. Okay, and then service and mood. Here again, we have a potential washout problem. Let's say that you're doing service for people and then you stop for like a week, but you're still like, you just have this really good sense of self. Like say you've been doing service for 5 years. It's part of your identity, and all that well-being and those good feelings are really pretty lasting because you're the kind of person who just does service for others, and that's really who you are. That can't really wash out. And so when you're selecting people to be in that study, you want to look at their experience in doing service, because it may be that if they've had experience and then you assign them to a non-service condition, their experience might last all the way through the non-service condition and give you the results of a person who's been doing service their whole life, instead of the results of a person who's not doing service for the past 6 weeks. And so that's another confound that you have to look for. Okay, now take a break, breathe. Great, getting that done. Okay, now we're gonna review a few concepts from the past just to make sure you have them. What's a variable, right? A variable is something that varies, something that changes. It could be the length of a tree. It could be the amount of caffeine you drink. It could be the temperature you study at. What are the data? Data are always plural. And so you say, what are the data? You don't say, what is it? Anyway, it's plural. It's a plural word. Most people don't use it in a plural way because they don't know better. And so you just kind of have to get used to using it in a plural way. Data are your results. What is methodology? Methodology is how you design an experience. What is the method that you're using to create your science? What is your study method? Are you at a between subjects experimental design? Is it a randomized controlled trial? Is it an observation study? That's your methodology. An observation is when you're looking at something, or you're getting a test answer or a survey question result. That's an observation. Variability is how much change there is, or how many different types of answers there are to a particular question. And so if you look at height, there's not a lot of variability in height. Most people are about the same height. You don't see very many 1-foot people walking around. You don't see very many 10-foot people walking around. Not a ton of variability in height. And so the average woman's height is 5'4". The standard deviation is 2 inches. And so that means that between 5'2" and 5'6", you have most of the population. 68% of the population will have their height be between -1 and +1 standard deviation, 5'2" and 5'6". And so there's not a ton of variability. Hopefully that makes sense. That's what variability is. Operationalizing, we mentioned earlier, an operational definition of something is how you are going to measure it. How are you going to measure this thing? That's how you're operationalizing it. So if I say, well, I want to see how this affects anxiety. What was our example? Exercise. I want to see how the kind of exercise I do affects anxiety. All right, great. How are you going to operationalize anxiety? That is the key. And so you say, well, I'm going to operationalize it by using this particular measurement. And so let's say you have the Beck Anxiety Inventory, and that's how you're going to measure your anxiety. That's your operational definition of anxiety. Results from the Beck Anxiety Inventory. That's how you operationalized anxiety. Validity and reliability. This applies to both a study and it applies to measurement. So when we look at internal validity, we want to look at the study. Does it tell the truth, or was it poorly designed? Were the things that manipulated the things that actually changed the result, or were there other things that might have also change the result. When you want to look at study reliability, really what you're looking at is replicating the study to see if you get the same results as the first study. If you're looking at a measure or questionnaire, survey, test, you know, those things basically all mean the same thing. You're looking at, does this questionnaire measure what it says it measures? If the questionnaire says it measures anxiety, does it like legit actually measure anxiety? Or does it really measure, you know, love of chocolate? And we just think that that is a measure of anxiety, right? Then it would not be valid. It would be valid as a measure of chocolate, not as a measure of anxiety. So you want to make sure it measures what it purports to measure. That's the questionnaire or the test or the measure validity. Does it give you the same results for the same issue every time? So if I'm anxious and I'm the same amount of anxiety every day, and I take this test and it says I'm different numbers every day when I'm really the same, that is not a reliable test. Okay, it needs to give you accurate, precise, similar results every time for reliability, and those results have to actually mean what it says it means for validity. All right, so next we're going to talk about chapter 5. Again, not a big deal. A lot of this at this point will be a little bit of review. There will be more information on internal validity. I'm going to have you watch a video on internal validity. So read the chapter, get kind of a sense of how to do the measures and what some of the issues with internal validity are, and then watch that video. And we will pick up after that.